Hello, my name is Marshal Covin. Here are my audience members for speech number 2. Now I want you to imagine for a second if you could edit someone's genome, fix a part of their DNA, and then prevent disease. This is actually no longer science fiction. As Ethan Weiss of the University of California explains, the new technologies such as CRISPR can prevent children from being born with deadly diseases or disabilities. But of course, this technology could not have been possible in the first place without the discovery of the structure of DNA. It was actually Rosalind Franklin's X-ray crystallography photo entitled Photograph 51 that allowed DNA structure to first be determined, as it demonstrated the double helix structure of the DNA. It is also called by Jeff Browell of King's College as, quote, arguably the most important photo ever taken. It was also used by Watson and Crick in their research to determine DNA's true structure. For me, as a biomedical science student at Texas A&M, this picture has had huge implications on my course of study and my future career as a veterinarian. And today I'm going to explain to each of you why it's also important for y'all. First, I will, as an overview, give you a little bit of information about DNA and why it's important, then talk to you about the influence of Photograph 51, and then finish off by telling you about the medical technologies that came about as a result of her photo. Here you can see Photograph 51 as well. Let us first take a look at what DNA is exactly. Well, the National Human Genome Research Institute defines it as something that contains biological instructions for each species to be unique, to survive, develop, and reproduce. It is composed of 4 different nitrogenous bases. Here you can see it as adenine, thymine, guanine, and cytosine, A, T, G, and C. These code in different orders in DNA to make up every single feature of living people. It's kind of how like letters in the English language make up words. Now, it's no surprise that DNA is such an important molecule, but it's unbelievable that a picture was actually the thing that unlocked its secrets. Now, prior to Photograph 51, it was hypothesized that DNA could have a triple helix structure. Lotta Friedholm of NobelPrize.org wrote how Linus Pauling, a famous chemist at the time, published a paper where he talked about the theory of a triple helix. In 1951, the scientists Watson and Crick also believed the triple helix theory to be true. However, they were of course all wrong. It is actually the fuzzy X in Franklin's Photograph 51 that revealed the double helix structure of DNA. Now, having seen Photograph 51, Watson and Crick were then able to adjust their theory. They combined the double helix idea with their previous research, and in 1953, they published a paper that outlined DNA's true structure. For this, they were awarded the Nobel Prize in Physiology. Lotta Friedholm of the NobelPrize.org also wrote that Watson believed Franklin's picture to be essential in their research and essential to the discovery of DNA structure, though she was never awarded the Nobel Prize. While it's unfortunate that she never won the award, what's undeniable is that her work and her photograph changed technology and medicine today forever. Now, as I began to explain earlier, we can now edit and manipulate DNA. Erica Hayden of Nature Journal explains how this girl, who was born with albinism and is legally blind, could have had her blindness cured early on with that technology, CRISPR. We can also change bacterial genomes to produce human insulin. The National Library of Medicine explains how the human insulin gene can actually be inserted into bacteria, and these bacteria will then start to produce human insulin, which can go directly to diabetic patients and help save their lives. We can also use DNA to help diagnose infectious diseases with a technology called polymerase chain reaction, or PCR. It is the most rapid method available today to detect infectious organisms. As a worker at the Texas A&M Gastrointestinal Lab, I also use PCR in my work to detect parasites and other multiple different kinds of infections in dogs and cats. Of course, none of these technologies could have been possible without Rosalind Franklin's Photograph 51. In summary, DNA is very important and at the heart of a ton of new technologies today. Were photograph 51 never created, we are unsure if DNA structure would have ever been determined. Thanks to Franklin's photo, we are now able to manipulate and change DNA to make insulin or to help diagnose disease. Unfortunately, Watson and Crick were the only ones who received a Nobel Prize for this work. But nonetheless, Rosalind Franklin's photograph 51 has changed the world and helped determine DNA structure, giving rise to these new technologies such as CRISPR that help save lives. Now, in the years to come, there's no doubt that photograph 51's influence will continue to rise as more technology and medical instruments continue to expand and become more advanced. Now, do we have any questions from the audience?
You were talking about PCR earlier. What exactly is that?
PCR is called polymerase chain reaction, and you actually take these things called primers, which detect part of DNA to help amplify that DNA, and then we see a curve on a computer that gives us different diagnostic capabilities so we can diagnose different organisms.
What was the method used to take photographs?
This photograph 51, was taken with X-ray crystallography. X-ray beams are actually shot into a crystallized, pure form of DNA, and the way that the X-ray beams diffract helps shed light on its actual structure. And that is how Rosalind Franklin took this photo. Any other questions? Thank you all very much for your time. Here are my audience members.